Here's integrated 3. This is section 1.4 and we're doing number 22. And so it's asking us a lot of different questions. It wants us to sketch and describe the solid. So there's two things we have to do. Make a sketch and do a description. And find the surface area and the volume. So they're asking us to do 4 different things. So we got to make sure we do all of the things that it's asking us to do. And we're in number 22. So I sketched this onto my paper, and what they're asking us is for a solid of rotation. So that what that means is they're taking this and imagining it going around and around, like spinning it around. So it ends up making a cylinder with a little cone on top. And I have a drawing of it so you can see what it looks like. It ends up kind of, as it spins around, see like this part, that's this. Okay, and so it's 11 all the way down, so from here to here is going to be 8. And so there's the drawing I got, so that's my sketch. My description, I'm just going to say it's a cylinder with a cone on top. That's my description. And then I need the volume and the surface area. So the volume, if you don't have that memorized, you can, I think in this Google Classroom here for your math oversight, there is a formula sheet, but you can also pick up one of these at the front desk. This is one of those planners that it has a bunch of stuff in the back of it. So I just went and looked for, there's my cone, and there's my cylinder, and see how it has a surface area formula and a volume formula for both of those. So if you want to pick these up, it's made out of paper, so you can just pull it out of this planner. It's just one of those planners from the front desk. Anyway, so that's where I got my formulas from, or you can Google them. So I have to identify what part goes where. So pi, I'm just going to use 3.14 for it. R is radius, so that's going to always be 4. My height of my cylinder is going to be, I almost made a mistake and said it was 11, but it's really only 8. So you just plug them in, and that's how you can get the volume. And I got the volume, but that's not, I'm not done, because this whole shape, it's also got this pointy part on it, so I have to add up. I got 1/3 times pi, and remember I just got this right out of the formula sheet here. Okay, that's where this came from. So I'm going to use 3.14 for pi. I'm going to use again 4, because if it's 4 up here, it's also 4 down here for my radius, and my height is going to be 3, and I got that because if it's all the way 11 all the way up and down, and if this is 8, that's got to be 3, because 11 minus 8 gives me the 3. So that's where that came from. Put that in my calculator. I got 50.24. I add that to the cylinder part, and we come up with this, which doesn't exactly match your answer book, but I rounded pi to 3.14, so I'm not surprised. I think that's acceptable answer though. Okay, and then surface area is how much, like if I wanted to cover this up in wrapping paper, how much paper would it take to cover the whole thing? Well, I'm not going to count this bottom part, right? This little piece right here, I'm not counting that because it's not exposed. So I can't just take the formula right straight off of this formula sheet, just blindly adding them together. I have to keep in mind that this cone is sitting on top of the, or on the bottom of the cylinder, and that there's only one of this round part right here. This is a pi r squared, so I have to adjust for that. So, and I do. So I got 2 pi r h plus, my formula told me to say 2 pi r squared, but I didn't want 2 pi r squared because there's only 1 pi r squared, because that's why I wrote there's no bottom. There's no bottom of my cylinder. So I just adjusted the formula. I wrote it right straight out of my formula sheet, except for I didn't put a 2 here because that part I don't want to count it. And then I plugged the numbers in. A 3.14 for pi, R was 4, H of the cylinder, that was 8. There we go. That was 8, and then I'm going to add that to the very top, which is pi r squared, and then I put that in my calculator. I got 200.96. Put that in my calculator. I got 50.24. Added them together. I got 251.2. But that's just for the cylinder part of my figure. Now I have to get the cone part. And so my formula sheet for cones, it said pi r L, and L, I don't know if you can see this, that little thing, that's the L. So on our picture, that ended up being 5. So I know that's L. And then I don't want to go the pi r squared part, because that's the bottom part. And we don't have that part, because that part is on the inside. So I've got, this video is getting long. So I've got pi times r times L, and that just came from my formula sheet, and then I'm not going to put the pi r squared on it. So 3.14 times 4 times 5, that made 62.8. So I'm going to add that to the whatever it took for the cylinder, which was 251.2. I add them together and I got about 314 square centimeters. And that's, I guess, why it's a challenge problem.